Welcome back to EduVibe. Today we will start with the last topic of 1D kinematics, which is the vertical projectiles and in free fall. So, so firstly, what is projectile? So not you have many information about the projectile. So projectile is an object that in any object is that is thrown and drop into the air. When we throw and drop, when we throw and drop anything into the air, we will do the projectile of that motion. If we will throw some ball over the air and we drop some ball down to the ground, so this will happen some projectile motion in that area where we can do this. In that case, resuming no other forces will happen in when we throw or drop some object from the air from the ground. So this will not resume in any other forces. There's only the one force, which is the earth's gravity, and the earth's gravity force is called the gravitational force. So that all the projectiles near the surface of the earth, which they are the near surface of the earth, experiences the some acceleration. In projectile motion we will more focus on the acceleration. Well, acceleration is that property which will cause the gravitational force. So acceleration causes the gravitational force exerted by the earth, and this is the force which is only exerted by the earth due to gravity. That's why it's called the gravitational force, which will happen when we throw or we will drop some object into the air. An object moving under the influence of gravity only is said to be a free fall. If we do any object which is influence, which will go with the influence with the gravity, which will go with the influence with the gravitational force, that object and that should be known as the free fall. Here we get the word free fall. So here we have like we do the acceleration due to the gravity. We will do some acceleration due to gravity. That's why we get the acceleration due to gravity term, and which is like g vector, because acceleration is a vector, and that case acceleration is equal to the g, which is the acceleration due to gravity, and this will denote as 9 point, that value is 9.81 meter per second square downwards. So there are three stages of the vertical projectile in specifically free fall. So the object in free fall explains the following stages of motion. So there are three stages, we will discuss one by one. So first stage is that the opposite and acceleration are in the opposite direction, so the ball slows down. If the velocity and the acceleration are in opposite directions, like if the ball goes like over there and this is our velocity, but the acceleration goes in the opposite direction. Acceleration goes in the opposite direction. So that ball slows down. When the ball comes to the ground, then our acceleration should be opposite to the velocity. So this will slows down the ball. This will definitely slows down the ball. Next one is that the ball momentarily stops at its maximum height. If we throw any ball into the air, at some maximum height, the ball stops at that maximum height, where our velocity comes to zero. And the ball then falls as the acceleration is still 9.81 meter per second squared down. And this will accelerate something. At the maximum height, this will accelerate something, and this will due to the gravity, which is acceleration due to gravity, and this will return the ball to the ground. This is the set stage that if there is a maximum height, it stops over there and then it falls as the acceleration due to gravity will occur at that stage. Next is the velocity and acceleration are in the same direction, so ball speeds up. If velocity is downwards and the acceleration is downwards, it is in the same direction and the ball speeds up. The ball speeds up and return to the ground. So using that information and using the information of the kinematics equations, if we as soon as we have that both things to be remembered in our mind, we will know how to solve these type of sums relating to the projectile motions. So the first question is that the ball is thrown straight upward which is 47.0 meter per second, how much time it does it take to return to its original release height? So we will throw the ball upwards, we'll throw the some ball upwards at some initial speed. So initial velocity we have 47.0 meter per second. Okay, and if the velocity goes upward, so acceleration goes down. So if acceleration goes down, so acceleration should be negative 9.8 meter per second square. They said that we have to find the time. Does it return to the original height? The ball is thrown from there, and how much time it takes to come at that height again. So we have to find that time, but when they goes at that height, so some final velocity should be there occur, and that was not mentioned that. So that our final velocity over there is 0. So like this. Now we have to find the time. So to find the time, we know that acceleration is equal to something, which is delta v upon delta t. And we know that acceleration is equal to final velocity minus initial velocity upon time taken. So we know that acceleration is minus 9.8 meter per second square. We know that final is 0, final velocity is 0, minus initial velocity goes upwards, so is in positive, so which is 47.0 meter per second. And yeah, the time is we have to find. So to find the time, we do, so 0 minus 47.0 is 47.0 meter per second, which should be minus. And we have minus 9.8 meter per second square. 1 meter per second square cuts out with meter per second square, and that meter goes out. We get time of like this minus those, and we get 4.79 seconds. And that 4979 seconds is for only one direction. We need that original time it take to return also. It goes up and it goes down. Like it goes up over there and it goes like to test that position too. So we know the whole time how much it takes. So we have to divide this by 2. How much time it takes to go up and how much time it goes to down. So it's to be divided of that. So 4.79 seconds into 2, we get 9.58 seconds. So this is the time the ball should take to return to its original height, where from is released to the. So let's do the another example, which is, yeah, the clone throws a ball upward at 10.0 meter per second to determine the maximum height that the ball reaches at above its launch height. So that the ball throws in the air about the initial velocity, so it throw at that speed of 10.0 meter per second, and some acceleration comes in the opposite direction, so which is due to gravity, which is 9.8 meter per second, but this should be negative because it goes like in opposite, in downwards. We have to find the maximum height, so we have to find the height from there to there. So this is d we have to find. This is that maths. And also if they goes up to this, so this on this state they have some final velocity too. So we have to find that final velocity, which is 0 meter per second. Not know that. So to find this, we know that some kinetic equations, that vf square is equal to vi square plus 2ad. From here we have vf square, which is 0 square, vi is 10 square, plus 2, 9.8, which is in negative. We have to find d. So from here 100 plus, we get negative of 1.962 d, and when it goes over there it gets like this. And D is equal to 100 upon 19.62. We get 5.097 meters, from where D is equal to 5.1 is in positive, so it goes like upward. So this is our distance, that maximum height. Next question, the part of this question that the time it takes to reach its maximum height. Now we have to find the time, that how much time it takes to that maximum height of distance. So in that case, we are Vi is same 10, Vf is 0, same. Acceleration is again minus 9.81 meter per second square. Now we have to get D of 5.10 meters. And now we have to find the time for this. So we know that D is equal to this also from the kinematic equation, that Vi plus Vf upon 2 times T. We know that distance is 5.10. We know that Vi is 10.0 plus 0 upon 2, and we have to find the time. So 5.10 is equal to 10 upon 2 times T. This goes on 5, and here 5 is multiplied, so it goes like divide from here. So you get time of like 1.02 seconds. This is the time it takes to reach at that maximum height of 5.10 meters. Next one is, now you have to actually find the ball's velocity at the height of 1.00 meters. It throws from the initial velocity of 10.0 meter per second, as we know. But how much velocity balls has at the height of 1.00 meters from the clone's hand? So we have to find the final velocity now. Now we have specific distance of 1.00 meters. We have to take that distance. Acceleration stays the same. Negative. Now again we're using that formula which we used, that Vf square is equal to Vi square plus 2AD. From here we get the Vf square from there. So Vf square is equal to 10.0 square into 2, which is minus 9.81, and what we have that D 1.00. Vf square is equal to 100 plus minus of this, so we get 80.38, and we have to do the root of this, and we get 8.97 meter per second. Is again in positive, so is the upward direction. So this is your final velocity of the height of 1.00 meters. That's all for this lesson and for this unit 2. So we will commit to the 1D kinematics from the grade 11th physics. In the next we will solve some extra questions from all the lessons, and we'll move on to the next unit, which is from the grade 12th unit. I will explain you about this in my next videos. So stay tuned with EduVibe, learn with simple with EduVibe. Please like, share and subscribe to my channel. Please, if you have any questions, like me in the comment section. See you in the next lesson. Till then, stay connected with EduVibe.